All right, good afternoon. Thank you for joining this session. So I will be talking about how we are using AI to discover undisclosed security fixes in open source packages, and also what this has to do with shadow patching. But first, let me introduce myself. So I'm Fred. I'm based in Ghent. I'm a software engineer at Aikido Security, which is a security platform where I work on AI autofixes. So what I do is our scanners detect vulnerabilities in your source code, for example, path traversal, SQL injections, these kind of issues. And we will use an LLM to create a fix automatically to patch these issues. So what you get is you get a diff, you get a PR, and then you review it, you merge it, and then all of your security problems are solved. More or less. Aikido is a security platform, just a small plug. We have about 10 different types of scanners. So we start at the cloud layer where we can scan your VMs for software packages, for operating system level packages. Then we have container scanning, we have software scanning, so at the source code level, and everything in between. But that's not what I'm here to talk about. So in order to talk about how we are detecting these unknown vulnerabilities in open source packages, we need to talk a bit about the open source supply chain. So probably a lot of you know how this works, but I'm just going to take a few minutes to walk through this. If we look at the amount of code that we have in our projects, about 85% of that code comes from open source projects. So we actually don't know a lot about that code. We know the interfaces, we know the APIs, we know how to use it. But what happens under the hood, we don't really know about these things. Many of these libraries, modules, packages have vulnerabilities. And there are people out there that are actively looking for these type of vulnerabilities, are trying to use open source projects to get into your application. So if you have your application, you depend on a bunch of packages, but in turn, those packages depend on a different set of packages, and those depend on yet another set of packages. As we know, this can go very deep, especially in the JavaScript ecosystem. They are very package inclusive, let's say. On the other hand, we rely on a lot of third-party services. So we have all kinds of services that we are using. Now, this picture looks quite clear, right? So we have some dependencies, we have some services that we use, but that's because this picture doesn't really tell the truth. In reality, it's more like this. So we have a lot of interdependent packages. There's a lot of services that are called through packages that depend on each other and stuff like that. So it becomes very difficult to actually know what is all of the stuff that's included in your project and how does it interact with each other. So let's say we have this small library here that has a vulnerability. Let's say this is called log4j, for example, and this is dependency of dependency. So we don't even know that we're including this. So this means that the other packages that included this, they are also vulnerable. And then our application, in turn, also becomes vulnerable. So in order to know what to do, we need to be able to get a good sense of what's going on in our application. And this is quite a difficult problem. This problem is also shown in this XKCD comic that most of you probably already know. So this is all modern digital infrastructure, and it all depends on this one small block there. That is a random project created by a person in Nebraska who is maintaining it since 2003, and who's not getting paid for it, who's not getting any credit. Nobody knows, but still the whole internet relies on that package working. There's quite a few examples of these. One of these packages, for example, well, the XKCD is called the Nebraska problem. One of these packages, for example, could be XCC utils or log4j, well, it's a bit bigger, or UA parser. So I'll go into the example of the UA parser. So UA stands for user agent. This is a JavaScript library that allows you to parse the user agent. It will pull out which browser are using, which operating system, stuff like that. So it's a simple library, but it's not something that you would like to rewrite, of course. If you look at the signals on this page, you can see it has 10 million weekly downloads, 56 versions. There's 1,000 libraries that depend on this. This looks like a reliable library to use, right? It's very often used. There are companies called Google, Meta that also use this, so I can probably also include this in my project. Although we can see that there's one author, so we have Faisal Salman, who is maintaining this project. So it's one person that is actually responsible for this. So this package looks good, we're using it. Now this happens. On a Russian hacking forum, this gets posted. It is a message that says, for sale, an account on NPM. You can buy the login and the password. It has access to a repository that has 7 million downloads every week, and 1,000 packages depend on it. And then the ad is really good. It says, well, it's suitable for distributing installations, miners, or a botnet. So buyers took notice, and somebody bought these credentials. What happened next? Over the course of 6 months, they started releasing new versions. They added new features to the library. They maintained it. The library still looked healthy, so it was being updated with legitimate updates. So the hackers really did a good job trying to increase the sense of well, the library being good. And so, but then after 6 months, they said, okay, enough of this. Everybody's using our thing. They're updating it regularly because we're putting out a lot of new features. Now we put in this DLL that can execute on your machine, and it contains a crypto miner and a credential stealer. So people who were updating to the latest version, they got this installed on their machine, and they were getting, their credentials were also stolen. Now, we don't know what the actual story is here, so we don't know whether Faisal was like, I've had enough of this open source stuff, I'm selling it. Seems unlikely to me. I think it's more likely that that person got hacked, that his credentials were stolen, and that then were sold. Because, yeah, they could have been stolen with something like this. So how do we know about these things? So there is a central database that contains CVEs. These are common vulnerabilities and exploits. These CVEs look a bit like this. So this is the CVE for the UA parser. You can see the affected version. So we have version 0729, 08, and 100 that are affected. And it also mentions the fixed versions. So a CVE tells you all of the information that you need to know about, like, is this library vulnerable, which was the version that are vulnerable, and where is it fixed? So if you look at CVEs, you will find these things. This is another CVE that might be familiar for some of you. Well, if you're ever been close to Java people, at least. So this is the CVE in log4j. This was a really bad one. So in log4j, they had an issue starting from one of the earliest versions of the project that was like 10 years old, something like that, where you could just insert a string that was very meticulously formatted, of course, and it would execute the code within that string. So this means if you have an API that's running on a Java service, all you had to do was try and put this particular string in all of the fields, see which of these fields was getting logged somewhere by log4j, and then it would execute your code on that machine. So perfect for getting access to somebody's network. At the time, I was working at New Relic. It's about 2 years ago, I think, and this was a really bad day. We had hundreds of services running Java, all having log4j. They all needed to be patched. This was a huge fire drill that went into the night, into the weekend to get things patched. And we didn't get to the last service like in 4 or 6 weeks, I think, and just because it was so widespread. And we were not alone. So if you look at statistics in December 2023, still 30% of the applications were vulnerable to this. All right, so cool. We have a CVE. So let's say we have, let's back up a bit. So somebody was looking at log4j, could be a developer of log4j, could be a security researcher or bounty hunter looking at the code and going like, ooh, this is weird. I think I can hack this. So what they did, they found the vulnerability, they disclosed it, created the CVE. This CVE then gets picked up by SCA tools. So this is software composition and analysis tools. What these tools do is they go through your application. They look at all of the packages that are being used, and they create a software bill of materials. This is just a list of all of the packages that get included by your application. And it's a transient list, right? So it's all of the packages that you use, but also the packages that are used by those packages and so on. So it's a complete bill of materials for your project. Then that bill of materials is checked against the CVE database to see if there's any versions of packages that are vulnerable. And then you get the output, which is a list of packages to update, because if you don't update them, then you can have remote code execution or bad reversal text or stuff like that. As you can see, the first step here is the disclosure of the vulnerability. So somebody finds a vulnerability and then they disclose it, they create a CVE for it. This is something that sometimes doesn't happen. So there's a thing called shadow patching, where people are like, okay, we have found something, we'll just create a patch for it, we'll release it, but we're not going through the hassle of creating a CVE. This means if the CVE is not in the database, tools will not pick it up, and you will not know that you're using a version that has a vulnerability in your software. So there are some reasons why people are not disclosing that. So it could be reputation concerns. So for example, as a developer, I don't want to admit that I made this mistake. Or it could be a reputation concern for your project, that oh, this is really bad if this project has such vulnerabilities and I don't want to use it. Although I think it's better for your reputation to actually disclose it and patch it as soon as possible to show like you care about security and you want to get it fixed. Another one could be a lack of resources. These projects are maintained by one particular person. They might not have the time or resources to actually go and create a report, submit it to the CV database, and so on. And the last one, which is also quite common, is the belief that this is fine. It's a minor issue. It's unlikely that anybody will ever exploit this, so let's just it's okay. We'll just create a patch and So this is what we want to do with Aikido Intel. This is our research project where we are trying to discover these vulnerabilities in open source projects that were shadow patched and create a directory where you can find these as well. So at intel.aikido.dev you can find this. This is open source, so you can see the whole feed coming through and you can just use it in your projects. So how does it work? We have about 5 million open source packages that we continuously scan. We gather the release notes for these packages. So we look at the changelog, at the release notes.md, these kind of files, and then we identify vulnerabilities that were patched in these versions. We look them up into the CVE database to see were there CVEs reported for these patches or not. If they were not reported, then there's actually a phase where one of our engineers goes through these findings and looks at whether it's actually an issue that should be reported or not. The tricky part here is, well, let me go through this first. So the sources that we have is we have a list of 5 million most popular open source tools that we go through. We scrape all of that data and then we format it in a standard format. Then we use an LLM to identify vulnerabilities. We cross-check with the database and then a human verifies it. So why do we use LLMs for this? The language in those changelogs and the formats are very ambiguous. So different projects use different types of formats, and different log messages are, well, different changelog messages are easier to understand than others. So for example, I have 4 examples here. On the first one, it mentions XSS as exploit. So cross-site scripting exploit, it's just in the text. Easy, right? This is definitely something that should be flagged. The second one mentions unauthenticated data access. Well, still quite easy. Third one, redact tokens that are logged to the console. It doesn't mention that it's a secret that's getting logged. It's already a bit more ambiguous. And the last one is hard. So it's like, increase the default work factor of this algorithm to 1 million iterations. It doesn't mention security, it doesn't have any type of exploit in it. It does mention like this type of algorithm that's used to create tokens from passwords, and it shows that it's doing something to increase that. So it might have been not good before. So these are quite difficult to see, and that's where we have the LLM that tells us like, likely this is an issue, and then the human reviewer goes in and checks it. Before LLMs, it would not have been possible to do this for us. So we are a startup. We don't have the resources to put 100 people to go through all of the changelogs and to manually identify this. Now with LLMs, we get a filtered version, which contains a lot less entries, which makes it plausible for us to actually go through these things. We have chosen to work with just the foundational models that are out there. So we're using the GPT models for this particular project. The reason for that being is that there's continuous improvement to those models. If you use your own model, a smaller model that you fine-tune, for example, you're stuck with it, let's say. You have to continuously invest in it. You have to make upgrades yourself, while if you're using the foundational models, you can surf the wave, basically. You can see how these models improve, and you can just get all of the incremental improvements while the models are getting better. The initial investment is a lot lower as well. You can get started really easy by writing a prompt, testing it out, and iterating on it. And of course, these models keep getting faster and cheaper. So that's why we are not doing any custom model or fine-tuning or stuff like that, but we are really leveraging the LLMs. So when you're developing with LLMs, there's a few things that you need to keep in mind. So as I mentioned, we start with a prompt that is spitting out potential vulnerabilities from these changelogs. And over time, we need to tune this prompt, right? So we need to know, do we have a good signal-to-noise ratio? For example, in the beginning, we had a lot of false positive coming through, where the LLM would say, well, these are all possible vulnerabilities, and we had to sift through a lot of that stuff. What we did there is we started building benchmarks for it. So we started marking this data. So whenever one of these log lines comes in, we say, okay, this is actually a good one that we need to look at, or this is irrelevant. So we give it a thumbs up, thumbs down kind of a rating. And we did this for quite a lot of data. And then we can use that to fine-tune our prompt. So we change the prompt and we see how the score changes over time. This also allows us to plug in new models, basically. So if you plug in a new model, you can see how it does against the benchmark. So it's really important when you're developing these AI agents, these AI systems, that you have some kind of a benchmark that you're building out, where you know what the answer should be, so that you can validate what changes in prompts, changes in models are doing to your performance. I think this is something where we see a lot of AI development going on, and I have the impression that a lot of people are just, I'm writing a prompt and it works, and they're assuming that that will always be the case. What we have seen over time is that models improve over time, but they also behave differently over time. So it's not because you switch from a model that was released last year to a model that's released this year that you're getting better performance. It could be that your prompt is really tuned towards the older model and does not perform well on the newer model. And that's where you really need to have benchmarks to make sure that you can track, like, how are we doing. For us, that's really important to get a good signal-to-noise ratio and to get an amount of issues that you can actually filter through and get good results out of. So talking about results, in 2024, we released this in January. We found 550 vulnerabilities that were not disclosed before. So about 56 of those were critical severity. So this means these were things that people shadow patched in their project. They just released it and said, okay, this is fine. To give you some examples, some interesting findings. So Axios is a promise-based HTTP client for the browser and for Node. This one has a prototype pollution that can happen. This is not a small project, so it has 56 million downloads every week. And there is no CV for this. So you should know that you should not use this particular version, that you should use the next version. Another one in the Apache Apache e-charts, 1 million weekly downloads. This is a less critical vulnerability, but it's cross-site scripting, so it's also one that was not detected. And then we have one in Laravel Composer, where it has 2 million installs, for a path traversal attack, path traversal vulnerability that was not disclosed. So if you go to intel.aikido.dev, you can actually see this. You can search for the packages that you're using. You can see the vulnerabilities that are coming up. You can also, of course, use Aikido, which has a SCM, an SCA that uses this feed as well as the other CVE databases. Where are we going next with this? Up next is malware detection. So what we're doing there is we're using traditional scanners to discover malware, potential malware, and then we use LLMs to triage the results. So here it's a bit the same concept as before. If you do this on a large set of open source projects, you will find 50,000 hits every week, something like that. So it's impossible just to go through all of these. So we're using LLMs to filter down again. So the concept there is the same thing as before. So we scrape all of this data from public registries. Then we use traditional tools to scan. So for example, Phylum or an OpenGrep. We then use an LLM to make sure that it's in the right format. And we ask the LLM to assess whether something is malware or not. So these detectors will do things like, I'm seeing something that is, for example, base 64 decoded, base 64 encoded in your software, or something that's zipped inside of the software. It's very suspicious because somebody might be hiding something in there. So we are building tools that actually decode these things, that unzip it, that look inside to see what's actually being put in there. And then the LLM will validate whether that's a malware, malicious finding or not. And then, of course, the last step again is human validation, where we check the results from the LLM to see what's actually up. So the early results, so we have been running this since the beginning of the year, I believe. We now have found 611 malicious projects in March 2025. And these are quite interesting cases. So it's a lot of typo squatting, where people are like a library that is one letter off from an official library. They include the original software, but they also include their crypto miner. So we do find a lot of those, and we flag them directly. So we benchmarked this against the OpenSSF, and they found 165 of these packages. So we are scanning a broader range, and we are finding more true positives as well. And that's it. That's all I had for today. Any questions?
So when you find these, do you go back to the projects and encourage them to file CVE, or are you now basically the only source of record for these findings?
So we also report them back to the projects, but we are not filing the CVs ourselves. So we don't have the authority to file the CVs, but we do report the owners that we have found this and that we are putting it into our database.
Yesterday, a news article is released that the CVE database is going down this week. Does that impact your organization?
That's a very good question.
Funding today.
Yes.
Yesterday, yeah, by the Dutch stuff.
Yeah, so Dutch cut the funding for Meter, I think it's called.
Yeah.
But there's another government agency that is picking up the project. So, but they might be next on the chopping block. That part, I don't know. But for now, the project is saved.
Okay.
Just curious, is Drupal core or Drupal contrib modules included in what you're scanning? And how do you decide if you have an ecosystem like this with, lots of maybe smaller independent projects in this larger ecosystem? How do you decide what's worth including?
Yeah, that's a good question. So I do think they are included in our scans, but I need to double check. So I'm not 100% sure. We look at our customer base as well to see what they are using to include into our scanning. So we do target the companies that are close to our customers, basically. And we do have a lot of customers that are using PHP, Drupal, and so on. So I do believe we have it covered.
That's it, I guess.
All right, I think that's it. Thank you very much.